If we would like to convert 18 over 24 into a decimal, what we need to do is first simplify our fraction, and then we will be working with easier numbers, or smaller numbers at least. So 18 and 24 have a HCF, or highest common factor, of 6. So we divide 18 by 6 and 24 by 6 to get 3 over 4. So now we are working with 3 over 4, which is equivalent to 18 over 24. So working with 3 over 4 is obviously a lot simpler and easier. So now we need to convert our 3/4 into a decimal. So firstly, the first option that we have is to get our fraction into an equivalent fraction out of 10, 100, or 1,000, and then do an appropriate division. So 4 does fit into 125 times, so we multiply 4 by 25 to get 100. We multiply 3 by 25 and we end up with 75. So 75 over 100 is equal to 75 divided by 100. So 75.0 divided by 100, which has 2 zeros, means we need to bring in 2 decimal places, and we put in our placeholders and our zeros. So we end up with an answer of 0.75. So that is one way of working out our fraction into a decimal. Another way of working it out is saying 3 over 4 is equal to 3 divided by 4. So 3 divided by 4 is equal to 3.000 divided by 4. It's always our numerator divided by our denominator. So our numerator will go inside the house and our denominator will be outside the house. So 4 into 3 doesn't go. We bring up our decimal point. 4 into 30 goes 7 times with a remainder of 2. 4 into 20 fits 5 times with nothing left over, so we don't even need that 0 there. So again, we get an answer of 75, which is the same as the answer that we got when we got an equivalent fraction out of 100. So you can use either of those methods. Right, let's have a look at 5/8. 5 over 8 is equal to something over 10, 100, or 1,000. So what we do is we convert 8 into something out of 1,000. We multiply 8 by 125 to get to 1,000. So we multiply our 5 by 125 and we end up with 625. So 625 over 1,000 is equal to 625 divided by 1,000. So we put our point 0 at the end to help with our working out, and we bring in 1, 2, 3 decimal places because we've got 1, 2, 3 zeros. So we end up with an answer of 0.625. Again, you can also use 5 over 8, which is equal to 5 divided by 8, and then do 5.000 divided by 8 in your division house, and you will get the same answer. Right, if we've got something simple like 9 over 10, all we need to do is we've already got a fraction that's out of 10, 100, or 1,000. So we just say 9 over 10 is 9 divided by 10. We bring in 1 decimal point, 1 decimal place because we're working with 10, which is 1 0, and we end up with an answer of 0.9. Right, if we are working with 3 over 50, 3 over 50, we need to get into an equivalent fraction, which will be out of 100 because 50 won't fit into 10. So we multiplied 50 by 2 to get 100. So we multiply 3 by 2 and we end up with 6. So 6 over 100, we can say 6.0. We can put in some placeholders there. Because we're dividing by 100 with 2 zeros, we bring in 2 decimal places and we end up with 0.06 as a decimal. Right, if we have 2/3 as our fraction and we would like to convert 2/3 into a decimal, we will see that 3 does not fit into 10, 100, or 1,000. And it's the same as if your denominator is 6 or 9 or 7 or any number that doesn't fit perfectly into 10, 100, or 1,000. What we need to do is our division. So we say 2 over 3 is equal to 2 divided by 3. And then we do this in our division house. So 2.000 divided by 3. And we'll just do it to 3 decimal places. We'll give 3 decimal places. We bring up our decimal point. 3 into 2 doesn't go, so we put a 0. Carry out 2 over. 3 into 20 goes 6 times. 6 times 3 is 18. The difference between 18 and 20 is 2. 3 into 20 goes 6 times with a remainder of 2 again. And so it continues. So we end up with an answer of 0.6 recurring. Right, let's have a look at one more example. 4 over 5. If we would like to convert 4 over 5 into a decimal, we get 4 over 5 into an equivalent fraction. We can get it out of 10. Because 5 times 2 is 10, we multiply our 4 by 2 to get 8. 8 over 10 is equal to 8 divided by 10. So we say 8.0. Because it's over 10, we bring in 1 decimal place because we are dividing by 10. And our answer is 0.8. So 4/5 as a decimal is 0.8. If we would like to convert 0.875 into a fraction, what we first need to do is consider how many decimal places there are in this decimal. So a decimal place are the digits after the decimal point. So there's our decimal point, and we have got 1, 2, 3 decimal places after the decimal point. So that means that we are going to get a fraction that is out of 1,000. Because we have 3 decimal places, our denominator needs to be 1,000 because that has 3 zeros. So if we only have 2 decimal places, it will be out of 100. If we have 1 decimal place, it will be out of 10, and so on. Now what we do is we ignore our decimal point and we have a look at what that number is, which is 0.875. And 0.875 is just equal to 875 because that 0 doesn't actually matter if it's in front of a whole number. So we've got 875 over 1,000. Now 875 over 1,000 is the fraction for 0.875, but it is not simplified. So we need to divide 875 by 125 and 125 by 125. So it's 875 divided by 125, 1,000 divided by 125, and we end up with 7 over 8. So 0.875 as a simplified fraction is equal to 7/8. Right, let's have a look at 0.04. 0.04 has 2 decimal places, so we are going to end up with a fraction out of 100. Because we've got 2 decimal places, we've got a 1 with 2 zeros, which is our 100. Then we ignore the decimal point because we've dealt with how many decimal places there are, and we see that we have a number 0.04 or just 4. So we end up with 4 over 100. We can now simplify 4 over 100 by dividing both the numerator and the denominator by 4 to get 1 over 25. So 0.04 as a simplified fraction is equal to 1 over 25. Let's have a look at 1.6. 1.6 is going to be equal to a fraction out of 10 because we only have 1 decimal place. And then we ignore the decimal point and we see that we have the number 16. So 16 is therefore our numerator. we now just need to divide both our numerator and our denominator by 2 so that we can simplify, and we end up with 8 over 5. And 8 over 5 we can also convert into a mixed number, which is 1, because 5 fits into 8 once, with 3 still over 5. So 1.6 as a simplified fraction is 8 over 5, or 1 3/5. Let's have a look at 2.5. 2.5 again is going to be out of 10, and we ignore the decimal point, we end up with 25 over 10. Now we just need to simplify. We divide 25 by 5 and 10 by 5, and we end up with 5 over 2. 5 over 2 can be simplified to 2, or can be converted into a mixed number rather, and that mixed number will be 2 1/2, because 2 fits into 5 twice, with a remainder of 1 over 2. So 2.5 as a decimal will be 5 over 2, or 2 1/2 as simplified fractions. Right, let's have a look at 0.88. 0.88, we have got 2 decimal places, so it's going to be out of 100. Then we ignore our decimal point and we see that our number is 88. We can now simplify 88 by dividing 88 and 100 by 4 to get 22 over 25. So 0.88 as a simplified fraction is 22 over 25. When we are converting decimals into percentages, we need to multiply that decimal by 100. It's as simple as that. So we multiply our decimal by 100. So we go from our decimal point and we go 2 places to the right. So our decimal point ends up after the 7. So we end up with 27.0% or 27%. 0.08 as a decimal is how much percent? Again, all we need to do is multiply our decimal by 100 in order to get our percentage. So we go from our decimal point 2 spaces to the right. So our decimal point ends up after the 8. So we end up with 8%. 1.02 is equal to what percentage? What we need to do is multiply by 100 again. So we go from our decimal point 2 places to the right. So we end up with 102%. 0.506 is equal to what as a percentage? Again, we just need to multiply by 100. So we go 2 places to the right and we end up with 50.6%. What is 2 as a percentage? Let's remember that any whole number we can write as 2.0. So there's our decimal. We can write any whole number as a decimal. So 2.0, we need to again just multiply by 100. We can put another placeholder in. So we go from our decimal point 2 places to the right and we end up with 200%. If we would like to convert 89% or any percentage into a decimal, we just need to divide by 100. So 89% or 89.0% divided by 100, we can put in some placeholders and we go from our decimal point 2 places to the left. So our answer as a decimal is equal to 0.89. 33.5% as a decimal. Again, all we need to do is divide by 100. So we're going 2 places to the left because our decimal point is going 2 places to the left, and that is because each of our digits are moving 2 places to the right in terms of place value. So our 3 tens is becoming 3 tenths, our 3 units is becoming 3 hundredths, and our 5 tenths is becoming 5 thousandths. So we move our decimal point 2 places to the left, even though we know that it's not our decimal point that moves, it's our numbers that are moving to the right. So our decimal point, in a sense, moves to the left. So we end up with 0.335 as our decimal. Right, let's have a look at 9.3%. 9.3%, again, we need to just divide by 100. So we can put in some placeholders. We go from our decimal point 2 places to the left, and we end up with 0.093. 18% as a decimal. Again, all we need to do is divide by 100. So we go from the end of our whole number, which is where the decimal point is, we can put 0.0 and we can put in some placeholders. We move 2 places back, so we end up with 0.18 as a decimal. And if we have got 105% and we would like to convert this into a decimal, again we just divide by 100. So we go from the end of our whole number 105 and we make it 105.0. We bring in 2 decimal places and we end up with 1.05 as a decimal. So 105% is equal to 1.05 as a decimal. Right, we are going to have a look at place value. 78.053. Let's have a look at the value of the 8 in this number. The value of the 8 in this number is 8 units, which is 8 over 1. The value of the 3 in this number is 3 thousandths, which is 3 over 1,000. Or in isolation, we would say 0.003. The value of the 5 in this number is 5 hundredths. So as a fraction, we would write it as 5 hundredths. And as a decimal, we would write it as 0.005. Right, and the value of the 0 in this number is 0 tenths. The value of the 7 in this number is 7 tens. Right, so let's have a look at another number. Right. We have got 4 thousands in this number, 0 hundreds, 2 tens, 7 units, 0 tenths, 0 hundredths, and 4 thousandths. So you can see how important these 2 placeholders are. even though they are zeros, they have a very important role in indicating to us that our 4 is 4 thousandths, because if we were to leave them out and put our 4 there, that would be 4 tenths and not 4 thousandths like it is meant to be. So that 4 would be 100 times smaller than what it's meant to be. And if our 4 was there, it would be 10 times smaller than what it's meant to be. So these zeros have a very important role to play. Right, so our 4 thousandths is 4 over 1,000, which is 0.004. Our 7 is 7 units, which is 7 over 1. Our 2 is 2 tens, which is equal to 20. And our 4 is 4 thousandths, which is equal to 4,000. Right, let's have a look at our 5. We have got 5 hundredths in this number, and that is because the 5 is in the second place value after the decimal point. So it is two places into our decimal places. So we have got 5 hundredths. The value of our 5 is 5 hundredths, which would be 5 over 100, or 0.05. The value of the 9 in this number is 9 thousandths, or 0.009. The value of the 6 is 6 tenths, or 0.6, or 6 over 10. And then we've got our 7 hundredths, our 0 tens, and 3 units. Right, so let's just have a look at the different numbers that we have. So let's consider this first number that we are working with. And if I was asked to find the difference between the value of the 8 and the value of the 5, so I need to then isolate the value of my 8, which is 8 units. So I can write it as 8.00 because I know here I'm working with hundredths. And then I minus, because difference means I need to minus. And then I minus 0.05 because the value of our 5 is 5 hundredths. So when I isolate my 5 hundredths, that is 5 over 100, which is equal to 0.05. So then I work out what that value will be. I borrow from my 8 to get 7, take my 1 over, borrow from my 10 to get 9, take my 1 over, and I get 5, 9, and 7. So the difference between the value of my 8 and the value of my 7, the value of my 8 and the value of my 5 in this number will give me an answer of 7.95. Let's have a look at our second number that we were dealing with. If I would like to find the difference between the value of the 4 on the left and the value of the 4 on the right, I need to isolate the value of the 4 on my left, which was 4 thousandths, so 4,000, and the value of the 4 on my right was 4 thousandths. Right, so that is 0.004, or 4 over 1,000. So I've got 0.004, and I put in my placeholders. Right, so what did I say? Should we find the sum of these two numbers? So if we were to find the sum of the value of the 4 on the left and the value of the 4 on the right, then we add together, because sum means addition and difference means subtraction. So we are going to add because we are finding the sum. So we add, now it's quite simple because we don't need to borrow, and we end up with 4,000.004. So the sum of the value of the 4 on the left and the value of the 4 on the right is equal to 4,000.004. Right, let's have a look here at this number. If I'm asked to find the product, let's say, of the 3, of the value of the 3 in this number and the value of the 9 in this number. So I've got 3 units, which is just 3. And then I need to multiply that by the value of the 9 in this number, which is 9 thousandths. So I'm going to write it as a fraction because I'd like to do my multiplying with decimals. I'd like to first convert them into a fraction and then bring it back into a decimal. So 3 units multiplied by 9 thousandths will give me an answer of 27 thousandths. So all I need to do is bring in 3 decimal places, because 27 over 1,000 is the same as 27 divided by 1,000. So I bring in 1, 2, 3 decimal places, and I end up with an answer of 0.027. So the product, which means that I need to multiply, the product of the value of the 3 in my number and the value of the 9 in my number is equal to 0.027. Right, if we have a look at this number 987.032, and if we are asked let's first have a look. What is the value of the 3 in this number? The value of the 3 in this number is 3 hundredths. Right, so in this number, the value of our 3 is 3 hundredths. Right, now if I'm asked how many hundredths are there in this number? So how many hundredths are there in this number? We would be tempted to say that there are 3 hundredths in this number. But that is actually incorrect, because in this entire number there's more than just 3 hundredths, because in all the place values before the 3, we also have hundredths in those place values. So we won't have any whole hundredths in the place values after our hundredths column, but we've definitely got 3 hundredths there. We will then, so let's have a look at our 7. In our 7 units, which is 7 over 1, we need to get that out of 100 to see how many hundredths there are in 7 units. So we multiply our 1 by 100, we multiply our 7 by 100, and we end up with 700 units. So as you can see, in our 0 tenths, we will also have 0 hundredths, because we multiply our 10 by 10, so we multiply our 0 by 10, we will still get 0 over 100. So that is more just a placeholder. But we will have 700 hundredths in 7 units. So you can already see there's 700 hundredths, and there's our 3 hundredths. So we've already got 703 hundredths in this number, but there's even more, because we've now got 80 or 8 tens, which is 80 units, and our 80 units will have, to get it into an equivalent fraction out of 100, we'll have 8,000 hundredths. So now we've got 8,000 hundredths plus 700 hundredths plus 3 hundredths gives us already 8,703 hundredths. But there are even more, because if we have a look at our 900 units and we get that into an equivalent fraction out of 100, we multiply our 900 by 100 and we end up with 90,000 hundredths. So we've got 90,000 plus 8,000 plus 7,000 plus 700, plus our 3. We end up with 98703, so 98,703 hundredths. And you can see that that number is much bigger than our 3 hundredths there. So obviously, if we are asked what is the value of my 3 in this number, there will be 3. Your answer is the value of the 3 is 3 hundredths, and that is because it is the second decimal place. It is the second column after the decimal point, which is our hundredths column. Right, or it's 3 over 100, however you would like to think about it. But how many hundredths are there in this entire number? There are many more. We have got 98,703 hundredths in this number. Right, so let's just have a look at another example. If we are asked, or let's rewrite this number, 987.032. Let's have a look at another way of seeing this type of question. So let's first convert this decimal into a fraction. Because we've got 3 decimal places, it's going to be out of 1,000. So we've got, then our numerator is 987,032. So what is the value of the 2 in this number? The value of this 2 is 2 thousandths. Right, but how many thousandths are there in this entire number? There are many more than just 2 thousandths. We've actually got 987,032 thousandths in this number, and that is because our number is already a decimal which we can convert into a fraction out of 1,000. So how many thousandths are there in this number? It's our thousandths column and everything before. Right, so how many hundredths are there in this number? We just need to divide our 1,000 by 10. So we bring in 1 decimal place and we get 98703 hundredths, if that makes sense. So we've got 98703.2 hundredths if we were to divide both the numerator and the denominator by 10. So because our denominator is now 100, we don't want a fraction of a hundredth, so we don't want 0.2 hundredths. We want to see how many whole hundredths there are in this number, which is equal to 98703 hundredths, like what we worked out before. So 98,703 hundredths. And as you can see, that is also just everything from the hundredths column before, and just excluding the decimal point. So let's have a look. 987.032. How many tenths are there in this number? So we know that we have got 0, the value of the 0 is 0 tenths. But how many tenths are there in this entire number? Well, we've got 9,000 tenths in our 900s. We've got 800 tenths in our 80 units. We've got 70 tenths in our 7 units. And then we've got our 0 tenths there. So we end up with everything before and including the tenths column. So how many tenths are there in this number? There are 9,870 tenths in this number, because 9,870 over 10 will give me that exact decimal that we've got there. It will give me 987.0, and that's what we've got there. So how many tenths are there in this number? There are 9870 tenths in this number. Right, and then obviously with our whole numbers, what we need to remember is that we've obviously got 7 units there. So what is the value of our 7? It's 7 units. And how many units are there in this entire number? There are 987 units, because in our 8 tens we have got 80 units. In our 900s we have got 900 units. So how many? So they are set therefore 7. The place value of our 7 is 7 units, but there are altogether 987 units in that number. So it all depends on how the question is asked. So what is the value of the 8 in this number? The value of the 8 is 8 tens. But how many tens are there in this entire number? There are 98 tens. Right. And so we just need to be very careful about how the question is asked, and you need to make sure that you are understanding it correctly so that you can give an accurate answer. We are going to have a look at rounding numbers off to the nearest unit. So if we have a look at 3.08, there's our units. We have got 3 units there. And when we are rounding off to the nearest unit, we need to have a look at the place value to the right of our units. And because we have got 0 tenths in this number, our 3 is going to stay as 3.00. So rounding, and that is because losing that 0 and the other place values is not much of a loss. So, and it is also, it's to say that 3.08 is closer to 3 than it is to 4. So 3.08 is closer to 3 or 3.00 than it is to 4. So rounding 3.08 off to the nearest unit is equal to 3. If we were to round the number 17.97 off to the nearest unit, what we need to do once again is have a look at our units. We've got, there's the place value of our 7 is 7 units, and then we have a look at the place value to the right, which is 9 tenths. So now we have a look, and if this number here is 5, 6, 7, 8, or 9, this value that we are rounding to will move up 1 digit. So that our 1 will always stay the same. Our 7, which we are working with, will become an 8. And that is because this 9 is in the category 5, 6, 7, 8, or 9. So that means that 17.97 is closer to 18 than it is to 17. So we end up with 18.00 or just 18. Right, if we have a look at the number 403.49, what we need to do is see that the value of our 3 is 3 units, and then we have a look to the right of our 3, which is 4 tenths. So we have got 4 tenths here, and this 4 falls in the category 0, 1, 2, 3, or 4. So if this number to the right of the place value that we are rounding to is 0, 1, 2, 3, or 4, like it was in the case with 3.08, then this value is not going to round up. It is just going to stay the same. So 403.49 is equal to 403.00 or 403 when we are rounding it off to the nearest unit, and that is because 403.49 is closer to 403 than it is to 404. Let's have a look at the number 599.87. So we are rounding with our units. So let's have a look at the place value to the right, which is our 8 tenths. So because we have 8 tenths, that shows us that 599 is going to be closer to 600 than it is to 599. And the reason for that is because our 8 falls in the category 5, 6, 7, 8, or 9. And that shows us that this 9 is going to move up by 1 digit. So obviously we're going to plus 1 to 599. So we plus 1, and that means we are going to end up with a 10 there, carry our 1 over, 10 there, carry our 1 over, and we end up with 600. And we can just think about it logically by saying that 599.87 falls in between the units 599 and 600. So 599.87 is in between 599 and 600, and we are just trying to figure out whether 599.87 is closer to 599 or closer to 600. And because of this 8 in our tenths column, we know that it is closer to 600 than it is to 599. So rounding this number off to the nearest unit will give us an answer of 600. Right, if we would like to round the number 7.08 off to the nearest tenth, we need to have a look. There's our tenth column. At the moment we have 0 tenths in our tenth column, and now we would like to consider whether 7.08 is closer to 7.0 or 7.1. So what we need to do is have a look at the place value to the right. So because this 8 falls in the category 5, 6, 7, 8, or 9, we know that this place value that we are rounding to is going to move 1 digit higher. So that 0, we are going to add 1, or we are going to add 1/10. We are not going to add 1 unit. We are going to add one of those place values, which happens to be 1/10, and we end up with an answer of 7.1, and then everything after that place value will fall away because we are rounding off to the nearest tenth, so everything after the 10th column will be 0. Right, so 7.08 rounded off to the nearest tenth will give us an answer of 7.1, and that is because this 8 in the hundredths column was grade 5 or greater. Right, so let's have a look at a very similar number, 7.04. And 7.04, we have now got a 4 in our hundredths column. So let's see what will happen to our tenths, because we are rounding to the nearest tenth. What will happen to our tenth if our place value to the right is less than 5? So if it's 0, 1, 2, 3, or 4. So because we've got a 4 in our place value to the right of our tenths column, we cannot round this number up. So we're not going to add 1/10 to that to this number. It's just going to stay the same, because this is telling us, this 4 is telling us that 7.04 is closer to 7.0 than it is to 7.1. So our answer will be 7.0 when we round 7.04 off to the nearest tenth, or just 7. Right, let's actually change this to a 6. So 59.362, if we would like to round this number off to the nearest tenth, we have a look at the value to the right of our tenth. So we've got 6 hundredths there, and that 6 hundredths tells us that we are going to round this number up. So we are going to add 1/10 to this number, and we will end up with 59. So 1/10 plus our 3/10 gives us 4/10. And then we've obviously we've got zeros after the tenths column, because everything after the tenths column will fall away or become zeros when we're rounding off to the nearest tenth. So this 6 tells us that 59.362 is closer to 59.4 than it is to 59.3. So rounding 59.362 off to the nearest tenth will give us an answer of 59.400 or 59.4. Right, let's have a look at this number 82.931. If I would like to round this number off to the nearest tenth again, I have a look at the value to the right of my tenth, which is my 3. I've got 3 hundredths there. So because this 3 is less than 5, that tells us that the number 82.931 is closer to 82.9 than it is to 83.0. Right, so rounding the number 82.931 to the nearest tenth, we are not going to round that number up. It is going to stay the same, and that is because of this 3 in the hundredths column. So we end up with 82.9 or 82.900. .977. If we would like to round this number off to the nearest tenth again, we need to have a look at the value to the right of our tenth, which is our 7. We've got 7 hundredths there, and because that 7 is 5 or greater, that is telling us that 6.977 is closer to 7.0 than it is to 6.9. So what we are going to do is we add 1/10 to our 9. So we're adding 1/10, and 1/10 is 0.1. And the reason we're adding that 1/10 is because of this 7, because it is greater than 5. And obviously these are going to fall away and become zeros because we are rounding to the nearest tenth. So we plus our 1/10 there, and we end up with 10, carry our 1, and 7. And again, that just shows us that 6.977 is closer to 7.0 than it is to 6.9. So rounding 6.977 to the nearest tenth will give us an answer of 7.0 or just 7. If I would like to round the number 9.037 off to the nearest hundredth, I've got 3 hundredths at the moment. The value of my 3 is 3 hundredths, and I look to the value to the right of my hundredths, and because this 7 is 5 or greater, that tells us that this value that we are rounding to is going to jump up by 1 digit, or we are adding one of those place values to the 3. So that's at the moment it's 3 hundredths. We are going to add 1 more hundredth to the 3 hundredths to get 4 hundredths, and that is because of this 7. We are going to round this number up. So we end up with 9.04, and we can put a 0 at the end if we would like, because everything after the hundredths column will fall away or become a 0 when we're rounding off to the nearest hundredth. Right, so let's have a look at a similar number, 9.032. 9.032 rounded off to the nearest hundredth again. We have a look at our thousandths column. We've got 2 thousandths in our thousandths column. So that 2, because it is less than 5, we are not going to round this 3 up. We are not going to add another hundredth to this number. It is just going to stay the same. So we end up with 9.030. 0 or 9.03, and the reason for that is because this 2, or the place value to the right of our hundredths, which we were rounding to, was less than 5. $82.766. If we would like to round this number off to the nearest hundredth again, we have a look at the place value to the right of our hundredths, which is 6 thousandths. And because this 6 thousandths is greater than 5 thousandths, we will round this hundredth off by adding one more hundredth. So 6 hundredths plus 1 hundredth, which is 0.01, will give us an answer of 82.77, and everything after the hundredth column will become a 0. So rounding the number 82.766 off to the nearest hundredth will give us an answer of 82.77 or 82.770. Right, rounding the number 99.997 off to the nearest hundredth. Again, what we need to do is have a look at our place value to the right, which is 7 thousandths. And because that 7 is greater than 5, we are going to add 1 hundredth to our number. So we end up adding 0.01. And that is because of this 7 here is telling us that the number to the place value to the left should round up. So we add 1 hundredth, and 9 plus 1 is 10, carry my 1. 9 plus 1 is 10, carry my 1. Bring down my decimal point. 9 plus 1 is 10, carry my 1. And then I've got 10 again. So we end up with 100 or 100.000. And the reason that we rounded this number we rounded it up and it didn't stay the same is because of this 7, and this 7 indicates that the number 99.997 is closer to 100 than it is to 99.99. When we are rounding off to the nearest thousandth, we need to underline the number that is in our thousandth column, which is a 9. So the value of this 9 is 9 thousandths. And when we are wanting to round off to the nearest thousandth, we need to have a look at the place value to the right of our thousandths, which is our 10 thousandths column, and we have got 2 10 thousandths there. So we now need to decide, is our number 5.0392 closer to 5.039 or closer to 5.0040? So these are our two options, 5.040, and that will be the bigger option. So let's rather actually make this the smaller option. So 5.039 or 5.040, because 5.039 would be one of our options, because that would be rounding off to the nearest thousandth if this number is less than 5, which it is in this case. And this would be rounding off to the nearest thousandth if this number in our 10 thousandths column was 5 or greater. But because our 2 10 thousandths is less than 5, rounding the number 5.0392 off to the nearest thousandth will give us an answer of 5.039, because our number is closer to 5.039 than it is to 5.040. Right, if we have a look at 1.7689, we again are going to be rounding off to the nearest thousandth. So we need to have a look at our 10 thousandths column where we have 9 10,000ths. And we then need to understand that because this number is 5 or greater, this digit is going to round up to 9. And that is because we are adding 1,000th to this number. So we are adding 1,000th, which is equal to 0.001. And we end up with 8 plus 1 is 9. And then our 6, 7, and 1. Everything else stays the same. So rounding this number 1.7689 to the nearest thousandth will give us an answer of 1.769, because 1.7689 is closer to 1.769 than it is to 1.768. So if we have a look at 1.7683, so it's very similar to this number that we were working with before, but now in our 10,000ths column we have 3 10,000ths. So again we are going to be rounding off to the nearest thousandth, but we have a look at our 10,000ths column to decide whether or not this number is going to stay as 8 or if it's going to become a 9. And because this 3 is less than 5, this 8 is going to stay the same. So we end up with an answer of 1.768 or 1.7680, because everything after the place value that we are rounding to will become a 0. Right, if we have a look at the number 9.9997, and again we would like to round to the nearest thousandth, we need to have a look at our 10,000ths column where we have 7 10,000ths. Now because that 7 is 5 or greater, we are going to round our 9 up by 1 digit. So what we are going to be doing is adding 1,000th to this number. So we add 0.001, which is our 1,000th, and that's because we are rounding our number up. So we end up with 9 plus 1 is 10, and 10, 10, bring down our decimal point, and 10. So we end up with 10.000, or just 10 wholes. So 9.9997 is closer to 10 than it is to 9.999, and that is because our 7 is 5 or greater. So even if the 7 was a 5, or if it was a 6, 7, 8, or 9, this number 9.9997 would round to 10 or 10.0000. But if this number 7 was, or the number in our 10,000ths column was less than 5, so if it was 0, 1, 2, 3, or 4, then our number would stay 9.999. Right, how many quarters are there in 0.75? So firstly, we need to understand what a quarter is, and then we need to be able to convert our 0.75 into something similar to our quarters. Right, so how many quarters are there in 0.75? That means what number over 4 as a fraction is equal to 0.75. So obviously, because quarters we're working with fractions is the easiest way to work with quarters, we would like to convert our 0.75 also into a fraction. So 0.75 as a fraction is over 100 because we've got 2 decimal places, and it's 75 over 100. So what did I do to my 100 to get 4? I divided it by 25. So I have to do the same to my numerator. I have to divide it by 25, and I end up with 3. So how many quarters are there in 0.75? There are 3 quarters in 0.75. So that is your answer, 3 quarters. Right, let's have a look at another one. If I were to ask you how many hundredths there are in 0.3, so a hundredth is something over 100. So how many hundredths are there in 0.3? And 0.3 we can write as a fraction as 3 over 10. So what did I do to my 10 to get 100? I multiplied it by 10. So I need to do the same thing to my numerator. Multiply it by 10, and I end up with 30. So how many hundredths is equal to 3 tenths, or 0.3? 30 hundredths is equal to 0.3. So our answer is 30 hundredths. Right, if I were to ask you how many eighths, which is something that is out of 8, how many eighths are there in 0.625? We first need to get our 0.625 into a fraction. We've got 1, 2, 3 decimal places, so that is over 1,000. And then we've got 625 over 1,000. And what we can first do here is try and simplify this fraction. So if we know our 125 times table well, which we should by now, we will know that 625 is a multiple of 125. 125, if we were to divide 625 by 125, we get an answer of 5. And if we divide 1,000 by 125, we get an answer of 8. So as you can see, we've already got our answer there. How many eighths is equal to 0.625? It's 5 eighths. So our answer is 5 eighths. Right, let's have a look at how many fifths there are in 0.4. So how many fifths is something over 5? So how many fifths are there in 0.4? 0.4 is equal to 4 over 10. And 4 over 10 we can again simplify down to 2 over 5. So 2 over 5 gives us our answer. How many fifths are there in 0.4? There are 2 fifths in 0.4. Right, if we are working with number sequences involving decimals, we work in pretty much the same way that we would if they were whole numbers. So what I would actually suggest you do in a case such as this one is ignore the decimal points and see if you can pick up some sort of multiplication pattern. So if you were to ignore those decimal points, we've got 3 there as our first number. We've got 12 as our fourth and 15 as our fifth. So hopefully you'll pick up that 1 times 3 is 3, 4 times 3 is 12, and 5 times 3 is 15. Therefore, we need to say 2 times 3 to give us 6, and 3 times 3 to give us 9. And obviously, because they were decimals, we also insert our decimal places. Right, so we were counting in 0.3s in this particular sequence. Let's have a look at another sequence. 9.8, 9, 8.6, and 8.2. So what we need to do in these sorts of sequences is pick the numbers that are next to each other and see if you can figure out some sort of pattern. So the difference between 9 and 8.6 is 0.4. And because we know that 9 is greater than 8.6, we would be minusing 0.4. And let's see if that is the same with our 8.6 and our 8.2. And the difference between 8.6 and 8.2 is indeed 0.4. So again, we were minusing 0.4 to get our next number. So we can assume that we would do the same thing to get our missing number here in our second place. So 9.8 minus 0.4 is equal to 9.4. So 9.4, the difference between 9.4 and 9 is also 0.4, so that works out perfectly. So what we were doing in this number sequence is just minusing 0.4 each time. Let's have a look at one more. 1.5, 4.5, 6, and another gap. So again, we should try and have a look at our numbers that are next to each other in the sequence. And what we can do is find the difference between these two. So we know 6 is greater than 4.5. So we can say 6.0 minus 4.5. You might be able to do this in your head, but it's best to just check anyway. We borrow from our 6, and we end up with 10 minus 5 is 5. Bring down your decimal point. 5 minus 4 is 1. So we end up with a difference of 1.5, and we were plussing 1.5 from 4.5 to 6. So let's have a look now to see what would happen if we were to plus 1.5 to our 1.5 here to get an answer of 3. Let's see if the difference between our 3 and 4.5 is also 1.5, because then we know our sequence is just adding 1.5 to each number. So the difference between 3 and 4.5 is indeed 1.5. We added 1.5 to 3 to get 4.5. So we can see that's what we need to do to our 6. We just need to add 1.5 because we have now figured out what the pattern is. So that will give us an answer of 7.5.